The portable source of electric current or electricity are called as what? Batteries. Batteries also work as galvanic cell as well as what? Voltaic cell. What's the example for primary batteries? The example for primary batteries are dry cell. Dry cell is also called as Leclanche cell. Anode is cylindrical zinc container. Cathode is graphite rod which is situated at the center, which is surrounded by powder of manganese dioxide as well as what? Carbon. Hello my dear students, I am Renuka Ashok, Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Welcome to 7th session of chapter Electrochemistry. In the previous session, that is in the 6th session, I discussed about how electrode potential can be measured and standard electrode potential and list of standard electrode potentials, Nernst equation. So, relation between equilibrium constant and EMF of a cell, relationship between standard free energy change and EMF of a cell, relationship between standard free energy change and equilibrium constant, difference between EMF and potential difference. These are the topic I discussed in the previous session, that is the 6th session of chapter Electrochemistry. Today I am going to do the 7th session of chapter Electrochemistry. In that I am going to solve numerical as well as I am going to discuss about batteries. I am going to discuss about batteries. Okay. The first one, numerical. So, this numerical is related with Nernst equation. Already you know that how do you measure electrode potential? Electrode potential can be measured by using Nernst equation. So, a zinc rod is dipped in 0.095 molar solution of zinc sulfate at 298 Kelvin. Calculate the electrode potential of zinc electrode. Calculate the electrode potential of zinc electrode. Zinc electrode. Its E naught of zinc electrode. E naught of zinc electrode is given by minus 0.76 volt. Minus 0.76 volt, as well as molar concentration of zinc ion. Molar concentration of zinc ion is 0.095 molar. You have to find out electrode potential. So, in the problem, we have to find out electrode potential of zinc electrode, but its standard electrode potential is minus 0.76 volt, as well as zinc ion concentration is 0.095 volt. 0.095 volt. As you know that Nernst equation is electrode potential of zinc is equal to standard electrode potential of zinc ion. Standard electrode potential of zinc ion minus 0.0591. 0.0591 divided by N log molar concentration of 1 by metal ion. Here the E naught value is minus 0.76 as well as N. How many moles of electrons are lost during this reaction? 2 log to the base 10 1 by 0.095. 1 by 0.095 because the molar concentration of zinc ion is 0.095. Now it is minus 0.76 minus 0.0591 divided by 2, it's equal to 0.02955 into log to the base 10 1 by 0.095. It is equal to 10.5263. Okay. So, the Nernst equation is given by E is equal to E naught minus 0.0591 divided by N log of 1 by molar concentration of metal ion to the base 10. Here the electrode is zinc electrode. We have to calculate its electrode potential, whose standard electrode potential is minus 0.76 minus 0.0591. During this reaction, the 2 moles of electrons are get lost. Therefore, in the place of N, you put 2 log of 1 by was the molar concentration of zinc sulfate or zinc ion 0.095. So, minus 0.76 minus 0.029, that is 0.224, 1.0224. After simplifying 0.79021 volt. After simplifying this, the value is minus 0.79021. So this is the answer for what is that? Electrode potential of zinc electrode when E0 is given as well as its concentration is given. Next problem. What is the equilibrium constant of the reaction? Equilibrium constant is Kc. When copper plus 2 silver ions give rise to Cu2 plus ion and 2 Ag. E0 of cell is 0.46 volt. How E0 cell and Kc are related with each other? E0 cell is equal to 0.0591 divided by n log Kc to the base 10. What's the relationship between E0 cell as well as equilibrium constant? Equilibrium constant is denoted by Kc. Equilibrium constant is denoted by Kc. E0 cell is equal to 0.0591 divided by n log Kc to the base 10. E0 cell is 0.46. 0.0591 divided by 2 plus log Kc to the base 10. After cross multiplying and simplifying, log Kc to the base 10 is equal to 0.46 into 2 divided by 0.0591. Okay, 0.46 into 2 divided by 0.0591 equal to 15.568. Therefore, log Kc to the base 10 is equal to 15.568. So, if you want Kc, it will become anti-log of 15.5668. So, anti-log of 15.5668. If you see the anti-log value of 3.688, it is 3.688 into 10 to the power of 50. Therefore, dear student, if you want to calculate Kc or E0 of cell, what's the relationship between E0 cell as well as Kc? E0 cell is equal to 0.0591 divided by n log Kc to the base 10. Log Kc to the base 10. Okay. What is the next concept? You have to deal with batteries. What are batteries? Batteries also voltaic cell. They are also galvanic cell or voltaic cell, but they are convenient to portable sources of electricity. It is very easy to carry. The portable source of electric current or electricity are called as what? Batteries. Batteries also work as galvanic cell as well as what? Voltaic cell. Therefore, what are batteries? Batteries are voltaic cells that are designed as convenient portable sources of electricity. Convenient of portable sources of what? Electric current. In batteries, we have two types of batteries. Primary batteries as well as secondary batteries. What are the two types of batteries? The two types of batteries are primary batteries as well as what? Secondary batteries. First one, let us consider primary batteries. Primary batteries are those which cannot be recharged. Once it is dead, once after using once, so the battery is dead, it becomes dead, we can't use further, so we can't charge it. So such batteries are called as what? Primary batteries. What are primary batteries? Primary batteries is one that cannot be recharged. For example, in maneli ಕ್ಲಾಕ್ಸ್ ಅಲ್ಲಿ ಟಾರ್ಚ್ ಅಲ್ಲೆಲ್ಲ ನೀವು ಸೆಲ್ ಯೂಸ್ ಮಾಡ್ತೀರಿ, ನಿಪ್ಪೋ ಎವ್ರಿ ಡೇ ಅನ್ನೋ ಒಂದು ಸೆಲ್. ಅದು ಖಾಲಿ ಆದ್ಮೇಲೆ ಚಾರ್ಜ್ನ ಪುನಃ ನೀವು ಏನ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ, ಅದನ್ನ ರೀಚಾರ್ಜ್ ಮಾಡೋಕ್ಕಲ್ಲ. ಒಂದ್ಸರಿ ಅದು ಡೆಡ್ ಆದ್ಮೇಲೆ ಅದನ್ನ ಮತ್ತೆ ರೀಚಾರ್ಜ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ನೀವು ಅದನ್ನ ಎಷ್ಟು ಹೊಸ ಸೆಲ್ನ ನೀವು ಕ್ಲಾಕಿಗೆ ಅಥವಾ ಟಾರ್ಚಿಗೆ ಹಾಕಬೇಕಾಗುತ್ತೆ. ಅಂಥ ಸೆಲ್ನ ನಾವು ಅಂಥ ಬ್ಯಾಟ್ರಿನ ನಾವೇನಂತ ಕರಿತೀವಿ? ಪ್ರೈಮರಿ ಬ್ಯಾಟ್ರೀಸ್. ಅಲ್ಲಿಗೆ ವಾಟ್ ಆರ್ ಪ್ರೈಮರಿ ಬ್ಯಾಟ್ರಿ? ಪ್ರೈಮರಿ ಬ್ಯಾಟ್ರಿ ಇಸ್ ಒನ್ ದಟ್ ವಿಚ್ ಕ್ಯಾನಾಟ್ ಬಿ recharged. In these batteries, reaction occurs only once and battery becomes dead when the cell reaction reaches equilibrium. Okay, very beautiful example of primary battery is dry cell. After it is also called as Leclanche cell. It is also called as Leclanche cell. It is used in transistors as well as clocks. It is used in transistors and ಮತ್ತೆ ಯಾವುದರಲ್ಲಿ clocks ಅಲ್ಲಿ use ಮಾಡ್ತೀವಿ. ಅದರಿಂದ was the example for primary batteries? The example for primary batteries are dry cell. Dry cell is also called as Leclanche cell. Now I am going to explain about primary batteries. In that, the very good example for primary battery is dry cell. Dry cell. Dry cell consists of a cylindrical zinc container. Cylindrical zinc container. Observe here, cylindrical zinc container which act as anode. Graphite rod which is situated at the center of this container, which is surrounded by powder of manganese dioxide and carbon which act as cathode. Therefore, in dry cell, anode is cylindrical zinc container, cathode is graphite rod which is situated at the center, which is surrounded by powder of manganese dioxide as well as what? Carbon. Electrolyte is a paste of ammonium chloride and manganese dioxide. Electrolyte is a paste of ammonium chloride as well as what? Manganese dioxide. A paste of manganese dioxide and ammonium chloride in water that act as electrolyte and fills the gap between anode as well as what? Cathode. At anode, zinc becomes Zn2 plus it going to lose 2 moles of electron. So MnO2 in the presence of ammonium ion takes 1 mole of electron and it will become MnO, OH as well as it liberates ammonia. These are the two reactions which takes place at anode and cathode respectively. The ammonia during this reaction at cathode, manganese reduced from +4 oxidation state to +3 oxidation state. Manganese reduced from +4 oxidation to +3 oxidation state, as well as ammonia which is get liberated, which reacts with zinc ion to give rise to zinc complex, tetraamine zinc complex, and this protects the swelling of the cell. This cell has a potential very nearly equal to 1.5 voltage. What's the cell potential of dry cell? The cell potential of dry cell is 1.5 voltage. 1.5 voltage. Here, what's the oxidation state change in the manganese? Manganese changes from +4 oxidation state to +3 oxidation state. Now, secondary batteries. Secondary batteries are secondary batteries that can be recharged by passing electric current through them in the opposite direction. Primary batteries cannot be recharged, but secondary batteries can be recharged by passing electric current through them in the opposite direction so that they can be used again and again. They are called as what? Secondary batteries. A good secondary cell can undergo large number of discharging and charging cycles. The most important secondary cell is the lead storage battery, which is used in automobiles and inverters, So, the example for secondary battery is lead storage battery, which is used in automobiles as well as what? Inverters. Now, I am going to explain the lead storage battery. It consists of electrodes made up of lead grid. Anode is a grid which is filled with spongy lead. Cathode is filled with a grid which is filled with lead dioxide. The electrolyte is 38% sulfuric acid. A fiberglass sheet which is kept between cathode and anode to avoid the physical contact. Therefore, lead storage battery consists of anode, a lead grid which is filled with spongy lead. Cathode is lead grid which is filled with lead dioxide, 38% of sulfuric acid which is act as an electrolyte, as well as fiberglass sheet between the grids prevent physical contact of cathode as well as what? Anode. The reactions which takes place at anode is lead reacts with sulfate ion, it will form lead sulfate by losing 2 electron. Lead dioxide reacts with sulfate ion and 4 H plus ions and 2 moles of electron, it will form lead sulfate and 2 water. The overall reaction Pb plus PbO2 plus 2H2SO4 give rise to 2PbSO4 plus 2H2O. Lead plus lead dioxide plus 2 sulfuric acid give rise to 2 lead sulfate plus 2 moles of what? Water. Now, fuel cells. What are fuel cells? As you know, hydrogen, methane, methanol on combustion. What is combustion? Burning with excess of air, it is called as what? Combustion. During combustion, the energy which is liberated that can be converted into electrical energy are called as what? Fuel cell. Fuel cells are also the galvanic cell which is used to convert the energy which is liberated during combustion of hydrogen, methane, methanol, and that energy is converted into electrical energy. Such cells are called as what? Fuel cell. Galvanic cells that are designed to convert the energy of combustion of fuels like hydrogen, methane, methanol directly into electrical energy are called as fuel cell. One of the very most common fuel cell is hydrogen fuel cell. Hydrogen fuel cell. It is used in the reaction of this hydrogen with oxygen to form water. This is the diagram of hydrogen fuel cell. It is consists of anode as well as what? Cathode. In this cell, hydrogen and oxygen is bubbled through a perforated carbon electrodes. Hydrogen and oxygen is bubbled through perforated carbon electrodes which are dipped in sodium hydroxide solution. Okay. In this cell, hydrogen and oxygen are bubbled through porous carbon electrodes into concentrated sodium hydroxide solution. Here we have to use catalyst like finely divided platinum or palladium. Metal are incorporated the electrodes for increase the rate of electrode reaction. Therefore, water vapors are produced during the reactions which are condensed. Therefore, in fuel cell, the catalyst used is platinum or palladium, which are electrodes, perforated carbon electrode. Through that, when you pass hydrogen and oxygen, they combine to form water. Water get evaporates, that water vapors are condensed. Next, fuel cells. In fuel cell, cathode O2 plus 2H2O plus 4 moles of electron, e raised to 4 moles of hydroxyl ion. Anode, 2 moles of hydrogen takes 4 moles of hydroxyl ion. It will form 4 moles of water as well as 4 moles of electron. The overall reaction is 2H2 plus O2 give rise to 2H2O. Hydrogen fuel cells been used for years, provide electricity and water during space flights, and fuel cell produce no pollutants. It is a non-pollutant and convert about 70% of fuel bond energy into power. If you use coal-fired power plant, it only converts 40%. If you use gasoline engine, it only converts 25%. But fuel cells convert how much of percentage? 70%. It converts 70% of fuel bond energy. Into power. If you consider coal-fired power plant as well as gasoline engine, they convert 40% as well as 25% respectively. Therefore, why the fuel cells are more efficient? Because they does not produces any pollutant to the atmosphere, as well as it converts the 70% of fuel bond energy into power. Next, the last topic of this chapter is corrosion. What is corrosion? When metals are exposed to air, their surfaces get oxidized to their oxides and sulfide due to the action of constituents of environment. If let us consider this is a metal, when it is exposed to air, their surfaces get oxidized to oxides and sulfides by the action of the constituents of environment. The very beautiful example for this corrosion is rusting. Rusting of iron is very good example for corrosion, as well as this rusting of iron is a complex electrochemical process. The least active metals like gold, platinum, they does not undergo corrosion, but almost all active metals, they undergo corrosion by the constituents of the environment. Example, silver undergo tarnishing, copper develops a green coating, lead and stainless steel lose their luster due to corrosion. Okay, silver undergo tarnishing, copper, there is a formation of green stains on the surface of the copper. The steel as well as stainless steel as well as lead going to lose its luster during corrosion. Corrosion causes enormous damage to building, bridges, ships and many other articles made up of iron. Iron does not rust in dry air and in vacuum. Iron undergo rust in only in moist air. It does not undergo rust in the presence of dry air as well as vacuum. vacuum. Rusting of iron is a common example of corrosion. Therefore, my dear student, what is corrosion? Corrosion is a process where the metals are oxidized to oxides as well as sulfides when they are exposed to air by the action of the constituents of environment. By the action of constituents of the environment, the metals are get oxidized to oxides as well as what? Sulfides. That phenomenon is known as what? Corrosion. The beautiful example as well as common example for corrosion is rusting of iron. Together with one, we can give an example of tarnishing of silver. There is a formation of green stain on the surface of the copper, as well as lead and stainless steel. They are going to lose their luster due to corrosion. And iron undergo rust not in dry air as well as in vacuum. Iron undergo rust only in the presence of moist air, and it is a complex electrochemical phenomenon. Rusting occurs in the presence of water and air. So, and it is a complex electrochemical phenomenon. So, it can be explained by taking, when you consider as an iron article, one spot, it behave as anode, anode. So, at that spot, Fe's get oxidized to Fe2 plus, Fe's get oxidized to Fe2 plus. Electron released here, that is electron released at anodic region, move through the metal and go to another spot, This spot act as cathode, this spot act as what? Anode, okay. In the same article, one spot act as anode where iron is get oxidized to Fe2 plus. These electron released at anodic spot move through the metal and go to another spot which act as what? Cathode, where that metal and reduce oxygen in the presence of H plus. Therefore, oxygen reacts with H plus and it will form what? Water. It will form water. Okay. So, the overall reaction is 2Fe plus O2 plus 4H plus give rise to 2Fe2 plus 2H2O. These Fe2 plus ion migrate through the moisture to the cathodic region where they are further oxidized to Fe3 plus and combines with the oxygen and water. And what is the Fe2 plus ions? Fe2 plus ions which are formed, which is migrate to the cathodic region, which is cathodic regional form ಆಗಿರುವಂತ Fe2 plus ions ಎಲ್ಲಿಗೆ migrate ಆಗುತ್ತೆ? Cathodic region ಗೆ migrate ಆಗಿ there it get oxidized to Fe3 plus, then it reacts with oxygen and water. Fe2 plus ions which are formed at anodic region which is come to cathodic region where it get oxidized to Fe3 plus which combines with oxygen and water to form rust. What's the chemical name of rust? The chemical name of rust is hydrated ferric oxide. Chemical name of rust is hydrated ferric oxide. Fe2O3 dot XH2O. So, the chemical name of rust is hydrated ferric oxide. Nowadays, how can you prevent this corrosion? Corrosion can be prevented by surface coating. Surface coating, that means oiling, greasing, painting, varnishing. So, iron rods, iron gates, wall, doors gella painting, oiling, greasing, varnishing madadrinda one we can prevent corrosion. Second one, so coating a thin layer of one metal on the surface of the another metal which is more electropositive. For example, iron's surface can be protected by depositing the metals, more electropositive metals like zinc, nickel, chromium. Zinc, nickel, chromium. Copper or brass can be protected by coating with a layer of tin. Copper or brass, its surface can be protected by giving a coating of tin. Iron can be protected by giving a coating of zinc, nickel and chromium. So, the tinning of brass utensils very common practice in our country, and by galvanization. Galvanization means giving a coating of zinc. When you coat zinc on the surface of the iron, then that phenomenon is called as what? Galvanization. What is galvanization? Coating of zinc on the surface of the iron to prevent corrosion. That phenomenon is called as what? Galvanization. Next, by connecting the metal to more electropositive metal. For example, iron can be protected from corrosion by connecting to a block or plate of zinc or magnesium. This method of corrosion is called as cathodic protection. What is that? Cathodic protection. So, the metal can be prevented from corrosion by connecting with the more electropositive metal. Example, iron can be protected by corrosion by connecting to block or plate of zinc or magnesium. It is called as cathode protection. As well as by forming insoluble phosphate or chromate copy. Metal surface are treated with phosphoric acid to form insoluble phosphate. Metal surfaces are treated with phosphoric acid to form insoluble phosphates, as well as using anti-rust solution. What are anti-rust solution? Solution of alkaline phosphates and alkaline chromates are generally used as anti-rust solution. What are anti-rust solution? Solution of alkaline phosphates and alkaline chromates, they can be used as anti-rust solution. For example, iron article dipped in boiling alkaline sodium phosphate solution, the protective insoluble film of iron phosphate is formed. These all are how to methods to prevent corrosion. So, corrosion can be prevented by oiling, greasing as well as painting and connecting the metal with another electropositive metal, or by giving a coating of electropositive metal on the surface of the other metal, as well as by dipping in anti-rust solution. What are anti-rust solution? Solution of alkaline chromates and alkaline phosphate. These are some of the methods to prevent corrosion. My dear students, I completed all the concepts of electrochemistry in all the 7 sessions. Thank you. Goodbye.